Thank you, everybody. It's humbling to be here. It's actually my 9th ClueCon, I think, and it's always a great pleasure to be talking about OpenSIPs in front of you. So I've been in the OpenSIPs space for the better of 13 years now, I think, and around the OpenSIPs headquarters in Bucharest, I do a little bit of everything from working on OpenSIPs modules to deployment stuff, even working on web APIs and whatever is needed to keep things running. So today I'm going to be talking about the latest release, the OpenSIPs 3.6, which just turned stable. So the beta testing phase is over a couple weeks ago. So now it's production ready. I'm going to talk about some enhancements we did as well to ease the development of your scripts and your services with OpenSIPs, and some integrations. And also a bit about the community editions. So in terms of operational, the first feature we put out was one that was requested for quite a bit of time now. But wasn't easy to fulfill, so we kept postponing it. People were asking, okay, I want to add an interface, an additional SIP listener into my OpenSIPs, but I don't want to restart the instance. Well, it's easier said than done, because OpenSIPs, it has a multi-process architecture, it forks all the processes, and now it's more complicated to have one socket shared by all of them, right? Because they're already forked. So we had to come up with a solution here. Răzvan did a great work here and made like a pool of processes that are able to dynamically work with these sockets that you provision in your database. There's a little table. From a usage perspective, it's quite easy. Like you just work with your sockets there, reload it, and that's it. It works. I mean, look at the configuration, right? It's just you set how big is this pool of processes, the max amount of sockets, and the DB URL, and you're good to go. Another feature which helps with the management of your OpenSIPs, and especially in parallel forking scenarios, right? If you've got maybe a class 5 service, we need to do maybe some hunt groups, let's say, right? Or you have users with multiple endpoints, right? Maybe they have a desk phone and a mobile phone, and you're doing push notifications and all of that. You will have to use parallel forking, right? You will have to ring them at the same time. And now comes the problem. Not necessarily on every scenario, but some of you, and of course we ran into this as well, we wanted to have better visibility of the data before we send out the branches and afterwards as the replies are coming in, right? If you're familiar with the OpenSIPs script, I have there on the left the preparation stage, let's say, when we prepare the branches, right? We set the request URI, you set the flags, and so on and so forth, and then you do append branch, right? You can, this way you set up some data, but as soon as you do the T-relay and the transaction starts, pretty much, right? Because at this point it was just preparation, you kind of lose all this data. So maybe you wanted to set some flags that you wanted to get back in the reply route, or maybe even you wanted to look back on some of the data that you had in the preparation stage. That is gone. That is all gone, and you have to pretty much hack your way and make AVPs. It's doable, right? But it led to some dirty scripting. So we wanted to make this a better process, and came up with this set of variables. So now you can see the unified format, right? There's branch, URI, destination URI path, flags, and so on and so forth on both ends of the transaction. And the data gets carried over. Also, if you notice, we added in some info there, the attributes, right? So now that is going to be really useful. You can mash in there any kind of data you want, maybe like a JSON or anything you want to retrieve once the replies start coming in. For example, one idea is I have so only one of the branches does SRTP, and I want to engage that if that is the winning branch, right? If that phone answers, if let's say you go out to PSTN and to Microsoft Teams, right? And on the Microsoft Teams branch, you want to do a little bit of different things, but you don't know which one answers. So now you have full control over the information across branches. Last but not least, you can look into other branches as well, because that was also a problem. The winning branch was number 2, or in this case, let's say number 1, but I want to fetch some attributes from a different one so I can terminate the session, for example, or similar processing. And a helpful function there to get a branch index using a given attribute. So useful stuff. Another big thing we worked on is related to SDP management. And things have been looking okay here, right? We are, almost 20 years into SIR and OpenSIPS, so on and so forth, and we haven't had problems managing the SDP. We've kept doing it with the substitute functions, right? Subs and subs body, and things have been working well. But as the years have gone by, the complexity of the SDP has increased, right? Look at this. Imagine, this goes beyond, by the way. It's like a 4 kilobyte or more. So imagine having to do a little change here, right? I want to change the bit rate of VP8 codec or something, right? You might get it, it probably will work, right? If you do like a big regex on it, but it might also do the wrong thing. It might catch data from the wrong stream, right? There is now a multitude of streams going on, maybe in a single SDP session, right? You can have video, you can have audio, there is conferencing stuff happening, DTLS, fingerprints. It's a lot of data in there that could screw this very error-prone way of doing it, right, with a subs and subs body. Not to mention it's inefficient. Maybe you want to do multiple of these changes. So, there is this ambiguity problem. You don't know which stream you're referring to. It's not real time, right? You make a change, but it's not immediately visible. And of course, you cannot work on a separate SDP. We start having these scenarios where we want to work with one SDP, and it's not the one in the currency message, right? And then pass that one to the RTP engine. You cannot do that. You have to hack it in some way, like loop the message and or other types of hacks. Run an external script. And maybe you even need to extract the codec lists, right? And you don't need the p-types of them, right? You actually need the names. So you need to do a bit of mix and matching. And that is quite difficult to do without any specialized functions, right? That you would pass to the RTP engine, let's say. The codec names, not the p-types. At any point in this, if you do it wrong, you end up with something like this. You probably have done it already. You can see the duplicated IPs here, right? Like a copy-paste one after the other. Or some other string you've made the same change on twice. So that's what happens in OpenSIPS, SIR, or all of these software which run with the lumps mechanism. So we said, OK, let's try something different. Let's work with a separate text processing engine here that won't break the script and will give us a good start for what's to come. So to start, we started with these variables that should give better control over the SDP. The first one is pretty self-explanatory. It's just represents the whole SDP as a whole, right? You could read it, fully replace it, right? But then there's line level processing, there is stream level processing, and there is session level processing. I guess maybe session is not that interesting. It's that thing that's on the very top of the SDP, right? Before all the streams. But anyway, you might have to change some data in there as well. Who knows? So quick look at how they work. The line is pretty, let's say, stateless. It just goes line by line. If you're not careful, you could walk over multiple different streams, right? Audio, video, but that's up to you to figure out. There is a way to quickly figure out which line you want to work with, right? With some string filtering and indexing, the first part, and then do a slash. Of course, it's optional. And you could even filter by attributes within that line. So it kind of just tokenizes it. Let's take a, hope it's visible. Let's take an example here. Just break it down into, with a white space, right, into tokens. And now you have a second index that you could either work with that way, right, 0, 1, 2, so on and so forth. Or you could even use a substring and further filter down which type of token you want to stop on. So we said that that is enough for the filtering. So now once you figured out which line you want, you could delete it. You can replace it with something else. You can insert something right below it. Or no, when you insert it's right on that line, right, and everything goes downwards. Or you could inject something right after it. So pick your poison. That should cover all your necessities here. Also, there's stream processing. So now, OK, we are going a bit more stateful. You can mix and match what type of streams you want, whether if it's the first video, second audio stream, and that kind of stuff. And then the same matching you had with the line variable, right? So similar operations, but now you're like delimited on the stream that you picked. And last but not least, the session, which is the first few lines of the SDP. There's this SDP.session variable, which helps you walk through them, match lines, and make the same kind of edits. And that's it. They're quite easy to test. We have a bunch of tests already. I guess if you take a look at the test file, you'll figure out exactly what you can do with, like at what kinds of lengths you can go with matching and working with these variables. There is also documentation on the website. And one more thing we did on the quality of life side, we added some configuration variables. It's not that you couldn't do this before. You could have easily done it with some kind of cache variables, right? Key values, which you can update externally through the MI. But we kind of made it a more wholesome experience. Just load the config module. It has a little table. You can provision key value type things. Let's say debug mode, right? Or similar things related to your service specifics. And you can override them at runtime, even in bulks. So there is also the config push bulk command. So if you want to maybe like automate some changes pushed into the OpenSIPs, you don't need to do lots of MI commands. You can do it via a single one. And that's about it here. There is also a tool in the control panel to help you manage the data. So that was as far as operational goes with 3.6. Let's take a look at integrations and what was done there. First and foremost, also this was a long requested feature. People wanted to do user location in Redis. OK, I want to put my users, my phones, right, my registrations in Redis. And there wasn't a really straightforward way of doing it because although it's powerful and efficient and so on and so forth, there wasn't the data type that we wanted. We pretty much wanted a a dictionary that you could filter by key, right? Not much to ask. But at most, Redis, the standard Redis gave us was a, not sure what they call it, a hash maybe. Yeah, but you couldn't filter by the hash keys. So, welcome Redis Stack Server. Has anyone heard of it? Redis Stack Server? Oh, nobody. Okay. Neither had we. I think it came from Norman, probably, or somewhere along those lines. He suggested, okay, there is this JSON support in Redis. So it seems disappeared in 2022, and they added all kinds of data types to Redis in this, what looks to be a separate project, but it's also open source. I'm not sure why they did it that way. So now you have documents, you have graphs, time series, search capabilities, and even tools for AI, like Bloom filters and for the AI pipelines. So yeah, we went ahead and completed the implementation. There is an interface in OpenSIPS that was just waiting to be implemented in the Redis driver as well, right? So that was it. So now user location works with Redis in both modes. But you need to have this Redis stack server up and running. Honestly, it just looks like a Redis. It's the same thing. It just has the features. And actually, yesterday when I checked the GitHub, now they have this little advisory that we are going to merge back with Redis in December this year, and we are no longer maintaining this Redis stack server separate thing. So I'm not sure what the heck is going on with Redis, but it seems to be going the right way now, right? They are unifying back again, and soon enough there will be JSON and JSON search support in Redis. The basic Redis, let's call it. All right. Speaking of databases, Peter Lemenkov also pushed a nice update to the Couchbase driver. If you like this document-oriented NoSQL database, pretty much he rewrote a big part of the code base to run on the latest driver, the version 3. Pretty sure it's backwards incompatible. But yeah, what can you do? You gotta keep up with the times, right? That's it for that one. Maxim went ahead with a nice update on the RTP front end and uploaded this RTP.io module, which is an OpenSIPS module that builds with the RTPProxy project, and pretty much it's a baked-in RTPProxy. The RTPProxy has a way of compiling into a library, actually, right? So all he does is wrote a little module that just loads this library, and there you go. You have a built-in RTPProxy into OpenSIPS. You can see if it works for you. It's most likely it's for some specific use case, like a good idea here, because obviously oftentimes you would prefer to scale them separately, right? You wouldn't want to have like a one-to-one OpenSIPS and RTPProxy. That's not ideally how you want to deploy to production. But in some cases, maybe you want a debugging instance, right? That could be easier to manage that way. Okay, I just install this OpenSIPS with built-in RTP relay. Could be very, very useful here. And there was also something going on the AWS side. First off, there is the simple queue service integration. So now we can be a producer for an Amazon SQS queue. You can do it at both script level with the SQS publish message or via events. So anytime, for example, in this example here, we connect the event OpenSIPS to the SQS queue. So every time it is raised, a message with the right content parameter gets pushed to AWS. And this was a popular one, actually, also with the AWS, with their NoSQL database, right? The DynamoDB. Okay, let's get some things going there as well. I don't want to sell DynamoDB too much. We don't work with it all that much, but I saw it works as a serverless right component. So it's not like you don't have that database. You just hit some endpoint, some HTTP endpoint with all your queries, and you pay per go, right? That's what. Yeah, how they sell it. Let's say could be. Yeah, if you're already having deployments there and you're running stuff, it could be worthwhile for you to use it now for your keys, right? It's a key value storage at the end of the day, or at least from what I know. Right, Janus also some contribution there from Vlad Paiu, a core OpenSIPS developer. And this one just helps connect to Janus and do both send and receive, pretty much like a connection manager with one or more Januses, of course. Like a Janus driver, let's say. And of course, the list goes on. Probably not that much time to cover all of it. There is a new allocator. Of course, if we had, 3, why not have the 4th one? That should be even more performant on certain use cases. The RTP engine functions are now async. You can use them in async mode as well, right? So you get better throughput on your OpenSIPs while waiting for the answer from the RTP engine. This one is a nice one. There is wildcard domains in support now available, so you can match a lot more domains using those wildcards. Yeah, authentication support in Cassandra, Unix URLs in MySQL, a couple variables you can use to improve your scripts, and so on and so on. The full list is available on opensips.org about version. Yeah, some stats on the release. 7 new modules, a bunch of enhanced modules, 840 commits, tens of thousands of lines added, some lines removed, thank God. Keeping things clean, right? And the repo still sits at around 200 megabytes. And it doesn't all stop here. If you remember from last year, I was alluding to the fact that we are working on these community editions. And they are projects, they are Docker-based solutions to help you get set up and quickly get acquainted with how all the pieces fit together, right? Because it doesn't help to have good documentation on each specific module if you don't see the bigger picture on how they all fit together or what is the use case, right? So that's what these Docker Compose projects aim to achieve. Yeah, they are fully working solutions. You just fire them and all of a sudden you got control panels, working RTP proxies up and running, and whatever is in that scenario, right? And you can kind of break it down and learn that way, which is probably much more fun to do, right? Understanding why something works rather than how can I get something to work, and I don't even know what to stitch together. So far, we have 3 projects, and since we are, AI is is a popular theme around here. We also have an AI connector written in Python, and it can work with the voice APIs from OpenAI, but also it can do like a more broken down scenario where you do the text-to-speech and TTS with something like DeepGram, right? And then get the text and pass it to ChatGPT or something like that. Another project focuses on the IMS and yes, how the call session control functions component would look like. It's all baked into containers, and of course there are also SIP cert tests. which also help you understand more about the call flows there. And there's also a soft switch community edition, right? And you just have to clone them and run Docker Compose up. That's it. Of course, you have to have Docker. And that's it. All the containers will fire up. There is a website for the community editions, a couple links for each project on the GitHub. And there's a mailing list on the CE projects as well. So that's all I had for you. The 3.6 release is the last of its series. It is an LTS, so it will be supported for 3 years. And for next year, we have already announced the 4.x series, where we kind of plan on doing some more drastic changes. Let's see. Yeah, I don't want to up talk it too much. Let's see what we can do in the next year. Any questions? Thank you for your attention.
Thank you, Liviu. Let's give Liviu a smashing round of applause. But if there are 1 or 2 questions, we just about have time. You know, I like to keep this ship pretty much on time. However, it's Liviu. It's not every day you get to talk to Liviu on stage. Any questions for Liviu here? Are you just yawning, sir, or is that a question? Ethan?
We have a question here from.
Oh, there we are. Yeah. Okay, let me hand this over. Here we go, sir.
Hello, this is Kishore from EcoSmoke. So you mentioned about IMS and CSCF, right? So will that cover all 3 components, I, P, and S? Actually, you caught me off guard. I think. So of course you can do all of them with OpenSIPs, right? You can do the proxy since we have IPsec tunnel support, and the I is not all that much special, right? There's just a querying type of service, and the serving one is the gist of what OpenSIPs does, right? But I don't know if there are actually 3 containers there or if it's just an. I would say there are, because it makes no sense. So we have, sorry, I haven't played with it that much. It's more on Razvan's side, but yeah, I would say that there is IPsec support. So
very incisive question from our friend there. One more question for Liviu before we move to Brandon. Brandon, if you want to come up and start getting plugged in, you're very welcome to do that. Any more questions for Liviu? In that case, let's give him a second ClueCon Chicago round of applause.